Hello and welcome back. Today we're going to continue explaining our node tree after we did the legs part. For those of you who just got here, I suggest you check out my first two videos, or at least the second one, since the first one is just like an intro into what are we going to do, and then the next video, the second video, is actually the first video of the tutorial series. Anyway, this file is available for you to download on the link right somewhere here. I don't know where I'm going to put it, and of course in the description. Description is obviously going to be below this video. And let's continue explaining. So the last time we finished our legs, and we got our legs, and now we need to start building the sofa, because this was the intentions were to make like a sofa, but then it grew to an object that can be a lot of things, including a table, chair, I don't know, whatever comes to mind. But since it was started as a sofa, we're gonna begin building a sofa, and the first thing after the legs we're gonna do are base. So I've already explained to you, so Shift Alt Control lets you see what's coming out of the selected node. So let's go right at the beginning. So obviously I made I'm definitely gonna enable the wireframe so you see all the edges. It's gonna come very useful, so you see the edges. Okay, so now what I did, I added a cube node, and with just 4 vertices, so we have like 2 loop cuts on each part, and this is what comes out. The only thing, of course, we needed our size, and so the default one was 1 meter by 1 meter by 1 meter, so we combine the X, Y, Z, and then plug the sockets into X, Y, and Z to set up the correct size. And the size is self-explanatory, so the depth and width is going to be our X or Y, and the base height, this one here, will control our height. And as you can see, since we plugged all these things into this, this is so the depth changes, width changes, and the base height also changes. So what did we do next? What did I do next? So the next node in line is this one. And what did this node do? So what did I do? Remember when I talked about the bevel thing? So the bevel, this guy over here. You know that until this moment we don't have a bevel node in geometry nodes, and I'm sure it's coming, and some of developers already did something like a bevel node, but it's not gonna come in our 3.0 version, because it's already in beta, so we're not gonna have it when it comes out, but I'm quite sure it's coming for 3.1. Anyway, until it becomes available, we're gonna have to find a workaround to bevel some edges, because there are no sharp edges like this perfectly vector shaped sharp edges in real life. So we need to find creative ways to create a bevel, because if I was to for example, from this node, when the loop cuts are here, and if I was to press Ctrl 2 to just add a bevel modifier, I just added a bevel modifier, you see that I am beveling on quite well on this side, but here it's a real mess. This is not the bevel that I want for like sharp edges, but just a little bit of a bevel, so half a centimeter or even less than that. And but if I move these edges all the way, I'm gonna create like a loop cut that's gonna allow us to bevel our object a bit more realistically. So how am I going to move these loop cuts over there? And it's simple. With the set position node, we already used it with the legs, and it's easy to select. So how I'm going to select these edges? So if I just undo this, unplug the position for just a second, you see that I need these on the, let's see, this is the x-axis. So all our vertices here have a negative and a positive value. So this vertices, this right here and right here, this is going to be the value of our width, right? So our width is 1.9 divided by 2, because this is 0. So in this we have 1.9 divided by 2 in this direction, also 1.9 divided by 2, and we will see them, it's our x. So this is it, look at it, these values here, and the other values are right here, and they are like this. So half a value divided by 3, so the whole width divided by 6, and this is our value on the plus and on the negative. So if we have like width of let's just say something like it's divided by 3, like 2.1, or maybe even better 1.8, so divided by 3, we will have, look at it, so this one is here, minus 0.3 is here, and 0.3 is here, and so on and so on. So how I'm gonna select these? Very simple, just with the help of our width, and divided by, I divided it by sorry, just the position. This is the position node, so I separated XYZ because I only need the X value, and I need to compare it to the value of 0. So he looks for 0 since I want the negative and the positive one, and I need to up this epsilon, and epsilon is going to be like a value that's covering all these in one direction and the other direction, and this is the dimension of the epsilon. So everything inside the value of epsilon is going to be selected. That's why I don't need to use like a boolean compared to minus 0.3 and plus 0.3, but just like compare it to 0 and add an epsilon, there needs to be at least this. But I upped it a bit, so I divided by 3, and that's because when you divide it by 3, this is like the value of 3, and it will select everything but, of course, so everything, kind of any value that's bigger than 2 and smaller than 6 would work in this case for selecting these two inside loop cuts. Okay, so once I selected it, I needed, okay, so let's connect it back. So I needed to be able to set this value exactly so that I can control my bevel, because the further away from the edge this loop cut is, the greater the bevel is gonna be. So how can I choose this exact value? And this is actually some mathematical conundrum, and to be perfectly honest, right now I don't even remember how I did it, but I just know that I did a bit of math like this, or geometry, and then I calculated, okay, I know this, I know what this is, and I know this and this, and if I want this to be like a number that's gonna be connected to my bevel, then this is the operation we need to do. Sorry, I don't remember exactly now, but you see it and you can check it out, and trust me, it's true. So whenever I change this bevel, this changes accordingly. So if I go here and change my bevel, you see that it increases no matter the size of the width. So see that it stays constant, this dimension right here. So that's the important thing. It's not that complicated anyway, just this. But there is a little trick that I needed to do to make it work the way it should. The bevel needed to be clamped, because I don't want this loop cut to go over on the other side. So if I go with the bevel, okay, if I increase the bevel, so now it's a small bevel, and if I increase it, when it comes near the middle, it doesn't go over, it just it gets clamped. So how do you clamp something? You just pass it through the clamp node, where you set so this value is getting clamped, this bevel value, and you set the minimum value and the maximum value. So when it reaches the maximum value, it just stops, and it comes out this maximum value. And what's the maximum value that I set? This is a math node where I multiply something and then I add something, but I'm actually dividing by 2, so multiply by 0.5 and then removing the 0.05 dimension. And why is that? Because I needed the width, so this is the width, and I divided it by 2 and I just subtracted 0.005. Okay, so that's how you clamp, that's how I clamp the bevel. And this is how I created this bevel thing. Okay, let's move on. This is practically the most important things I've said. And the next, I did the same thing for all 3 dimensions. So I did it for the y value, the same exact thing, but this time I clamped the bevel with the depth, because this is now the point where the bevel line should stop. So you see that now I'm having like a small bevel, and then I increase it, and now here it stops for the y axis and it continues to go until the middle of the x axis. And the same thing happens for the z value, as you can see from here now. The z value is the same exact thing. So look at this, look at these 2 loop cuts. We have like smallest bevel and then slightly increase it, and then this one stops right here. But if the base was bigger, let's just increase the base height like a lot, base height, and then this bevel on the z-axis would be like this, still stopping in the middle. Okay, so this is how I did my base object, and then I passed it through the transform node where I set the exact position of it, but we don't need it. We don't need to change the x and y, since the x and y is right in the middle and the base is covering the whole object. I just needed to move it on the z value, and I needed to move it exactly half a value of the base height, right? Base height divided by 2, and of course add the height of the legs. Okay, so that's exactly what I did. I did the base height and the legs height divided by I added the legs height and divided the base height by 2, and that's the z. Look at it now. Okay, so this is up, since this is where our legs are gonna go. And then I added a subdivision surface node, boom, and connected to this socket levels of subdivision. As you can see, we have a lot of levels of subdivision that we can change here, and I wanted to be able to change it from the modifier side panel here. And so I connected to sub-D, and now sub-D parameter is what controls this, but the bevel is huge, so where is the bevel? Right here. Okay, and then the bevels are shape. Okay, perfect. And then the material, just connected to the material base. So socket, this is where you're gonna choose the material for our base. And then again, shade smooth, but simple here because we want to shade smooth everything. So we just pass the node through and enabled it. We don't need to select parts of it like we did with the legs. Okay, and then everything that comes out, that came out here, the legs, and this what comes out of here, the base, is going to be connected to one and only join geometry node. So everything I'm doing in these steps is going to be selected in this, is going to be united and connected in this join geometry. It's going out in this node, and we're going to have this little cute thing. Okay, let's go forward, and now let's deal with the base. We did it, so now let's deal with the back, and the back is this little back thing. And now I managed to complicate a bit these things now, since I did two backs that switch on and off, or depending on whether these cushions, back cushions, are here or not. And so what did I do? I created a simple back, and I think this is the simple one. No, this is the complicated one. So this is the simple one. This is the simple back. And how I did it is, it's really, I don't want to show you anything from here because it's the same process I did with the base here. So everything is identical. The only thing is the size that is not directly connected to some of these sockets, but you need to do some math. And of course, the bevel thing that I showed you is the same thing I did for these. So same exact thing. Beveling on all three axes. And here is the transform node where I needed to place it where it needs to go. And this here is also a bunch of geometry math nodes where you just need to figure out exactly where this needs to go, because it depends on the shape of everything that goes around it. So you'll notice that if I remove this side, the size of the back changes. So if I remove this side, look, 1 or 2, the size of the back changes. And how did I do that? That's the only thing that's kind of new here. And let me show you how I did this. So this is where I did it. So the size of it changes. And the size changes according to existence or non-existence of the side size. Okay, so what did I do? I needed to subtract the dimension of the side thickness from the width, right? So I'm subtracting from the width the side of the dimension, the thickness of our side. But what happens when we have no side? This is where it got kind of simple, because this is my side, no one, yes. This is what gives me, where is it here? This is what gives me an opportunity to have no sides, one side, or both sides. So what does this sends out? It sends a 0, a 1, or a 2. It sends a 0 if you don't want any sides, 1 if you want one of them, and 2 if you want both of them. And it's quite simple because I'm just multiplying the side thickness to that number and then subtracting that number. Because if I have 2 sides, then I need 2 side thickness to subtract from the width. And if I have no side, then I have 0 times side thickness to subtract. So it's not going to subtract anything, so it's going to remain with same width. And that's how this width changes with this side number. Not side cushions, but side number here. See? But then we got into the same problem when we needed to transform this. So we needed to translate it because it was different. It always needs to go, when we have 2 sides, it needs to be in the center. But when we have 0 sides, also needs in the center. But when we have 1 side, then it needs to go a bit like half a side thickness to one or the other side. And that's where you need to get a bit creative. So we needed to clamp. This is what I did actually. We need to clamp, divide, multiply, subtract, all these weird things to make this translation work on the x-axis. This was a bit complicated. To be perfectly honest, I don't recall exactly what I did, but you can see it here and check it out for yourself. But that was a challenge also. Okay. Let's go back to this other back. And this other back will appear, and this is what I talked in the last video, if you remember, when we have cushions. So when we have cushions, we have this, like this looking weird back. And how I did this. Okay, first let's see how I altered between one or the other, but that's not that difficult. We have this switch node, and this switch node, it lets you, like, this is a boolean, back cushions yes or no. So when these are true, when we have a back cushion, then this geometry is false, so it doesn't output a thing. And the same switch is down here, so when it's true, it outputs the other thing. So practically I just so I'm setting this at false and this at true. So when this is false, this one is going out, and when this is true, this one goes out. And if this is true, nothing comes out of it. So it's a way to shut down geometry or to choose from one or the other geometry. So when there are no side cushions, this one is stopped, and when there are side cushions, not side cushions, sorry, back cushions, the other one is going out. Sorry, we need to like go here. Back cushions or not back cushions. See? It's just totally different geometry that just gets sent out or stopped. But are two completely different objects. Okay, so this second back is a bit different, since okay, I needed to be a little bit more creative here because I actually wasn't able to do the bevel thing here, because first I needed to do this. So I did the bevel here on this side, but for this I fortunately wasn't able to do it. and I also did the small bevel here. But this line and this line here needed to be in line with the cushion height and thickness. So, and also this line here, and so unfortunately I wasn't able to bevel this part up here. We're gonna have to wait for the bevel node to do that the way it was supposed to be done. But anyway, I've already told you about this in my previous videos. I think the first videos I talked about that and how I did it, but I don't want to go all over the same thing. It's always the set position node and some selection. So how do I select this? I selected it's the same practical same techniques where I compare it to value, give it an epsilon, and then I select these values and then I move them this way, like just separating an x value, and I add something to that x value that goes here, and so it changes accordingly. Okay, so that's practically the back. I did the same thing here, so subdivision surface modifier with the value to sub D here, and a material socket here, and the shade smooth that always gets shaded smooth. Okay, so now we did the back, and maybe I could finish this video right here. And next, okay, we're just gonna do the side because the side is practically the same thing. It's even simpler than all of the others. So the side, always the size combined, depends on the depth and all these things. Okay, and I did the bevel, the same bevel thing I did with all of these boxes, and then the transform node where I placed it where it needs to go, and then I copied it, remember, and then I copied it to create copy on the other side, but I also added one of the copies to be switched off if I want side no yeah. So so I can choose one or two sides. So side no yes, 1 or 0. Okay, it's because we have the 0 this on this switch. So this is the 0 switch, and this is the 1 and 2. But okay, here, yeah, because 0 switches all of this geometry from here, and this one here switches only one of these two. Okay, then subdivision surface, shade smooth, and switch set material, and so on. Okay, and next we are left with, okay, the base 2. Another thing that I really don't want to go over, this is the base 2. Let's just like put it up. It's the same exact thing, but with this back thickness combo. So this node is actually this node, and this one gets a bit complicated because this base 2, if we go into our like this node to see everything, so this is our base 2, and our base 2 changes a lot depending on this piece right here, and this one is the back piece. So back, it changes. If the back is not here, then the base becomes big as the base below it, but if it's here, then it changes. it gets shorter by this distance, and this distance is the back thickness here. Back thickness, back thickness, back thickness, like this. And this is no problem at all. But we have that other combination that when you have your back cushions, then we have a different back. And this also needs to change, this one here. And we actually do not know what value is this, because when we like back height, if we increase it, you see that the thickness of it also increases. And that's because we needed, this line is always here, depends on where the cushions are. So if the cushions are lower, this line gets lowered. But this angle of this plane right here behind the cushions is always the same. So this thickness depends on the side of the height of the cushions, the thickness of the back, like in this part, and the height of the back. So this is a lot of things to do here. So what did I do? I did like a node that helped me to manage all of this, and since its value is going to be used a lot, I needed to create it. I called it the back thickness combo. So in this node, it always comes out the true value of this based on whatever I do here. So this is the back combo thickness. And what's in it? This is just a group of nodes. So if you want to create a group of nodes, you just select two nodes and press Ctrl G, and it's going to create a group. Then when you can then maybe I'm gonna Shift D, just demonstrate it like this, and then Shift G, and then it created a group node with its output and its input, and then you can change whatever you want with it and add like stuff, and then change it, and then it's gonna look like let me just undo all these things. It's gonna look like what it looked like here. It's gonna look like something like this, sorry, let me just delete this, something like this. And this one actually has another group node inside of it. Let's check it out. And this is the true back depth. So this true back depth is the depth, it's this dimension right here, when this back is with the cushions. And let's go inside this one also. This is very simple. It's just the back thickness that gets added, the backside height and cushion thickness, subtraction, and then divided by 5, because this is the angle of the angle is 1:5 ratio. This is the angle I chosen, so divide by 5 to subtract. So this is practically the this value right here. It's this divided by 5, so I need to add this to get this. Okay, so and what happens with these nodes? So if I have like these need to connect outside, from the outside inwards with these values, and they come out as true back depth. This is how I called it. You can change the names of this, but I called it true back depth, and that's this dimension, so I know what's coming out. And then I use this node to use it in this node that's coming out as this back thickness combo. And because sometimes this value is not going to be this, but when we have like that square looking back, then this is going to be the back dimension, back thickness. And so I used booleans, and with multiply value I just made it output one or the other dimension depending on the back cushion's yes or no boolean. So this is like switch between this true back depth and the depth of the thickness of the back. That's this. I just multiply it with 0 or 1, and then I add the 2, and okay, whatever. Okay, so that is it, I believe. Go up like this. I just went with, so to go into a group you just go into tab, and then tab to go back, but in these cases you like end up in a loop between these two, so you can use also this little button to go up a row. And the base, everything else is what we already did, what we already done. So like set position with the bevel on 1, on 2, and on 3 dimensions, and then of course transform to place it. And this is where it also got complicated, because it's also placement depends on the back thickness. So I used my my back thickness combo again, and my back thickness, and all these things to put it in the place where it needs to go. And again, subdivision surface, set material node, set shade smooth. This is a switch. This is a switch. Okay, this is a switch for yes or no for base, so if I want it or I don't want it. And that's it for the base. And the only thing we've got left is the cushions, and that's I will do that in the next video, and I'm sure it's going to be the last one. So thanks for sticking out with me, and I'll see you in the next one. Bye bye.